Welcome to the Advanced Topics module for the Programming Bootcamp. In this module, we're going to cover some things that you may not see in an introductory programming course, but these are really important tools for you to know as a programmer, and these are things you'll definitely see in your introductory programming units. The first thing we're going to have a look at is file processing. So by file processing, we mean reading data from a file and also writing data to a file. So these are really common tasks that you need to do as a programmer. Sometimes you have configuration files or data stored in files that you need to read into your programs. And also often you need to actually store data from your programs into a file. File processing involves three main steps. We have to open the file, and then we're going to do the thing we want to do, the reading or the writing, and then closing the file as well. With Python, we have two different styles that we can use. We can use the with keyword, and we say with open, the name of the file, and then a second parameter, and then this tells us what we're doing with the file, whether we're reading or writing. So in this case, we'd be reading, and then we can grab all the data that is in our file. Once the scope of our with statement here ends, we no longer have access to our file, but we can grab all of the data from it and then loop through it and use it in our programs. The other style is to explicitly close the file. So instead of using with, we just use open. We open our file, we read in the data, we can loop through it and use it in our programs, but then we have to explicitly close it as well. So sometimes you need to do multiple reads and writes, in which case you'd have to use the second style here. So the flag, the second parameter in open, tells you what you're doing with your file. You can read, you can write to a file using the W flag. Note that writing to a file will overwrite all of the content in the file. Often this is not what you want to do. You would want to append to a file. So in that case, you can use the A flag to do that. So we'll have a look at some file processing in code. So I have a file of usernames here and a high score separated by a comma, and we want to read all of this data into our program in Python. So we'll have a look at the first style. So that's using with. We just say with open and then the name of the file that we're opening, and then a second parameter tells us what we're doing with the file. In this case, we're opening for reading, so we use the R parameter. We name the file, and then we can grab all of the data from the file using the name of the file and then read lines. So this will grab everything in one go. So once we're here, once the scope of the with statement has ended, we no longer have access to the file, but we've grabbed all the data in the file and stored it in a variable for us to use. So then we can loop through our file. So we just say for line in lines, and then we can print out each of our lines in our files. So the other thing we want to do when we do this is we want to actually strip off any white space or trailing characters, which will often be there, even though you may not see them in your files. So we do that just using .strip on each line. So when we run this file now, we can see that we've read in all of our data. The other thing I'll point out is the location of your files to read. So if you want to not actually state the explicit path here, you can store your files where your file lives in your project of your Pycharm project. If your file was elsewhere, then you'd actually have to give the full path to where it is. So that was using the with statement. We can also not use the with statement, in which case we just say open. All of the code, the rest of the code is exactly the same, so I'm just going to copy and paste. The only difference being here is that we actually have to close our file as well. So this is probably more often used for writing the files. Usually when you read a file, you may just grab it all and read it. You don't need to keep your file open, but it's handy to know both ways as well. So the difference being here that you actually have to close your file using close. So when we run this now, we see that we have our list printed out twice. So writing to a file is the other thing we can do. So when we write to a file, we use exactly the same notation as reading, except we're going to actually change the second flag here. So the second parameter we're going to call W instead of R. So we can say new users, if the file doesn't exist, it will create it for you. So we'll say W as out file in this case. Now to write to your file, you use .write, and then you can add anything that you want here. So the other thing you usually would want to do is to add a new line character. So this will ensure that every line that you write is on a new line. So when I run this code now and I go and check my directory, I have a file here called new users, which should have one thing in it, which is new user, which we just added. So that created your file, wrote in new user. The other thing we can do now with our file is append to it. So this will make sure that we don't overwrite any data that was already in our file. So if I run my code now, we can see, open up our file, you can see we've got 2 new users, and you can see what the new line character does. If we didn't put the new line character in, they'd be on the one line here, and you continually get data written to the one. So they're the main things you want to do when processing a file. You want to read or write or append to a file, and you will have to do this often when programming too. So the next thing we're going to have a look at are dictionaries. So a dictionary is very similar to list, but we have an unordered set of key and value pairs. So by unordered, we say that the keys don't have any specific order in the dictionary. A key is the thing here, which are our strings, in which case oranges, bananas, apples, pears, watermelon. These can be an integer or a float or a string, and the values that are associated with each of the keys can be anything at all. So they can be a string, or they can be a number, they can be a list, and they can also be another dictionary. So we use curly brackets when we create dictionaries. So we'll have a look at some dictionaries. So I have a dictionary of fruit here, which has all of the keys and a value associated with that key. So although we create a dictionary using curly brackets, we actually access the things in our dictionary using square brackets. So if this was a list, we'd have to pass in an integer, a number, to access anything in our list. But for a dictionary, we actually give it the name of the thing we want. So in this case, we're asking for the thing in our dictionary called oranges, and it should return to us the value of oranges. So when I run this code now, you can see it's returned to us 455, which is what we expected. So you can also change anything in the dictionary quite easily in a similar manner using the square brackets, and we can set a new value. So now when I actually print out, so I'll print out all of my dictionary, you'll see that oranges has been updated from 455 to 555. So also with dictionaries, you'll want to loop through your dictionary. This is a very common task that you'll want to do. So when we loop through a dictionary, we're going to get all of our keys returned to us. So if I say key in fruits, and then I'm just going to print out what we get back. So remember, this here is a variable name. It could be called anything. I'll just call it key. So when I run my code now, we're going to get all of our keys returned to us. So this is not always what you want back from your dictionary. You may want your key, but you may also want the value of the key. So we can just access that as well. So we can say fruit of key, and in this case we get all of our keys and all of our values, so you can access all of the data from your dictionary in your code. So we note that a dictionary is not sorted, so there is no notion of having a sorted dictionary, but if you wanted to retrieve everything in a sorted order, then we can just simply add the sorted function to our keys. Now when I run my program, we're going to get everything returned to us in sorted order, sorted by the keys. So they're the main things that you want to do with the dictionary. You usually just access and you'll loop through and you'll change values. You can also just simply add things to a dictionary just by, again, using the same notation. So if I wanted to add another item to our dictionary and give it a price as well. Now, when I run our code, you'll see that we have everything we had previously, but we also have grapes in our dictionary as well. So they're very easy to use. They're a very handy data structure to use as a programmer. And if you become confident in using dictionaries, you'll find that they'll save you a lot of time as a programmer. So I really encourage everyone to practice using dictionaries whenever they can. So the final advanced topic that we're going to have a look at, sorting algorithms. So we've seen how to sort a list in Python. It's actually quite easy. There's a function for us to do that. It's just .sort, but behind every function is an algorithm that implements that function. And for sorting, there's a lot of choices to use to sort a list. So most of these algorithms that are listed here, you're going to see in your introductory programming units. They're used not only to sort lists, they're also used to analyze programs, and in particular, the complexity of a program. So by complexity, I'm talking about how long your program takes to run and how much memory it uses. So the time and space complexity. And this is something you'll definitely come across in many of your units. So sorting algorithms are a really common algorithm used to analyze algorithms as a whole. So we're going to have a look at a couple of these common sorting algorithms. The first algorithm we're going to have a look at is selection sort. So what selection sort does, it will loop through all of your lists and then it finds the smallest thing in the remaining part of your list and it will swap them as we go. So our outer loop here loops through your entire list except for the last thing in your list, because this will be sorted already when we get to it. And the inner loop here says, let's find the smallest thing in our list and swap that out with where we're currently at in our outer loop. And the code here does your actual swap. So we're going to have a look at that in code, but I'm going to show you in another sorting algorithm first. Before I do that, we'll have a look at a diagram for selection sort. So in understanding a sorting algorithm, it really does help to visualize it, either with a diagram or an animation. If you look up online, you'll find animations of most of the common sorting algorithms. So we start at the first thing in our list, and then we say, let's look at the rest of the list and find the smallest thing in it. In this case, it's 4, and then we swap those two. So you can see here, 10 and 4 have been swapped. We then move to the next item in our list and say, is there anything smaller? We try and find a smaller number. If there is, we would swap them. In this case, there wasn't, so 8 stayed where it was. We then look at the next thing in our list, 10. We see that 9 is smaller than 10, so we swap those two. We then move on to the next item in our list, and we need to swap those. And then when we get to the last item in our list, we can see that it's actually already sorted. So selection sort is a good starting sorting algorithm to try and understand. The next algorithm we'll have a look at, and the final sorting algorithm we'll have a look at, is insertion sort. So insertion sort doesn't rely on swapping out elements. It will loop through your entire list, which is what your outer loop does. And then it tries to find the correct place to put the current item. So your inner loop will push along all of your lists until it finds the correct place to insert the current item from your outer loop. So again, it's very helpful to try and visualize any sorting algorithm before you try and code it or understand it. So we start by assuming the first thing on our list is already sorted. Then we move to the next thing in our list and say, where is the correct position to insert that into our sorted list? So 8 needs to be inserted before 10, and that's what we do. We then move to the next item in our list and say, where is the correct position in our sorted list to insert that? In this case, it's at the start. So in doing this, you can see that we have to the left in the green here, we have a sorted list, and then everything to the right is unsorted, and we're going to move to the right and sort as we go. So we'll have a quick look at selection sort and how to code that from scratch. So I'll get rid of the call, and we have a list that we want to sort, and we're going to use a function for selection sort, and we're going to pass in a list and implement the selection sort algorithm to sort our list. So the first thing we need is the length of our lists. Then we need to loop through everything in our lists. For I in range, I'm going to actually use index here just to be a bit more clear about what we're doing. So we're going to loop through all of our list, but the nature of the algorithm, we know that the last thing will be already sorted. So we can say for n-1. So what we do is we assume that the thing we're looking at is the smallest thing in our list. So we're going to say that's the minimum index, and then we're going to check the rest of the list to see if that's true or not. So we start another loop, and we're going to loop from where we're at +1, so the next thing in our list, until the end of our list. And what we're checking for, we're checking if that is smaller. We have a syntax error. The thing we're looking at, the I in the inner loop, is smaller than the thing we have. If that's the case, we want to set that as our new minimum index. So we'll do our check. If that is true, then we then set min index equal to I. Jump out of the loop. So when that loop runs, min index is going to hold the position of the minimum value in our list. So once this loop ends here, we then need to do a swap of the values. So firstly, we'll use a temp variable to store our value. So we're currently at index, we're currently at the position in our outer loop. We're going to store that value, then we can set it equal to the minimum value, which we know is at min index. So we store, then we can set the thing that was at min index equal to our temporary value. So this is swapping the two values using a temporary variable. So that is insertion sort. So we can actually run our code now by calling our function that we just created on our list, and then we're going to print out our list. So we're not returning anything, we're actually just going to pass in our list to get our function to sort it. So you can see we have a list up here. We're going to call selection sort, pass in our list, and then we're going to print out our list, and we're going to hope that it is sorted. And you can see that we have a sorted list using selection sort. So sorting algorithms are really good to visualize using your debugger. So your debugger is excellent for debugging your code, but it's also very good to analyze your programs and to visualize what is going on with your program. So in previous modules, you've seen how to use the debugger. So we set a breakpoint. So I'm just going to set a breakpoint when we first call our function. Then instead of running our code, we use the bug for the debugger, and we get the debugging console. So a debugger will show you the values of all your variables as you step through each line in your code. So we can see we start with our unsorted list, which is down here, and we're going to loop through our lists. We're at position 1 here, position 0, so the first thing in our list. Then we're going to do our check and say, is there anything that is a smaller value than where we currently are? So we're looking for anything that's smaller than 31 in this case. So every time it finds something smaller, it will set that to the new index, which it will go through. So once that for loop runs, we now have in min index, we have the position of the smallest thing in our list, and we're going to do our swap. So what we should see here is 31 and -4 be swapped. So when we go through our code, we can see list has been changed and -4 has been swapped with 31. We're now going to move in our outer loop to index 1, which is 22 here, and then we're going to check the rest of the list again to try and find the smallest value and perform a swap. So we continually do that. You can see what the debugger does. It actually stores and tells you the current value of all of your variables in your program, which is a very handy thing to know when you're looking for bugs. And also, it's very handy to actually understand what your algorithms are doing. So as we go through, we can visually see our list being sorted. It goes from an unsorted list as we loop through, and we finally get to our sorted list, which we print out. So I really encourage everyone to have a go at writing their own sorting algorithm, whether you try and write a selection sort from scratch or an insertion sort from scratch. And when you do, have a go at using the debugger as well.